More parts came in. Let's check it out. Electronic components. Well, that's a good start. That's what I want to open. And we have bubble wrap. And inside the bubble wrap looks like a little module. Some sort of sensor maybe. I think I ordered this very recently because I think it's the latest thing I got from the mailbox. So we can maybe, oh, it's open on both ends. Maybe we can actually gauge how long this took. And it looks like standard I2C interface. And it looks like it has some sort of optical interface on it. Oh, RGB gesture. And is that an I2C address of 39 hex? Considering I think I ordered this really recently, I still need to go and look it up and be sure what this is. One piece is APDS 9960 RGB and gesture sensor module I2C breakout board breakout for AR. Arduino? $2.48 US from Satisfy Electronics. This is the Spark Fun. I don't think so. RGB and gesture sensor. So that's the sensor number, APDS 9960. It can do ambient light and color measuring, proximity detection, gesture sensing. Has a detection range of 4 to 8 inches, 10 to 20 centimeters. And here's some more info on the datasheet. Gesture detection utilizes 4 directional photodiodes to sense the reflected IR energy sourced by the integrated LED and converts motion, such as velocity, direction, distance, into information that we can use. So they have a built-in LED, and then there's 2 different sets of information. The gesture and motion is sensed by these photodiodes for up, down, left, and right, and then they do things to process it. But you can also detect colors and things. Red, green, blue, and clear light intensity. So you can measure ambient light and sense the color and do various things based on that information. And you have a simple I2C interface and an interrupt, so it looks relatively easy to use. I'll be curious to see what it can do. Also received recently, electronic components, no commercial value. Well, they have value to me, so let's get at it. Oh, potentiometers. And some stuff. It looks like switching converters. I don't know if it's buck or boost. 2 of the same, MT3608. So, what does this look like? Clearly labeled V in and V out, a potentiometer to set the voltage, a chip, capacitors, inductor, and a diode. Let's go see if it bucks or boosts. 2 pieces of MT3608 step-up power apply booster module, DC to DC, 2 volt to 24 volt, 2 amp new from Satisfy Electronics, $12 US for both. Very simple, straightforward design. A little tiny 6-pin chip. Tiny board, 36 millimeters by 17 millimeters by 14 millimeters. Looking at the MT3608 datasheet, it looks like all those specs are confirmed. 2 amps step-up converter, an integrated 80 milliohm power MOSFET, input voltage 2 to 24, there's a current limit of 4 amps, and the output can be up to 28, and a tiny 6-pin SOT23 package. That pretty much matches what the listing said, which is impressive. But I'm wondering about this 2 amps, and at what voltage can you get 2 amps, and does this tiny package have enough power dissipation? It automatically switches its mode of operation for light loads, has under voltage lockout current limiting, and thermal overload protection to prevent damage in the event of an output overload. I don't really see anything in here about how to tell the power handling capability of this and how to gauge what input to output voltages versus your allowable load current you can safely do before you cause a problem. But if it has thermal overload protection, maybe we can just try this experimentally and see when it shuts itself down, do an empirical design. So here's this one chart with load regulation, and they just have an example. It looks like they're targeting around 5 volts out. And it looks like when you start going above 900 milliamps, you have some problems with a 5 volt out. But what's the input voltage? Does it matter? You know, what about at different voltage outs? How does this all look? I don't think the datasheet has enough info to clearly tell me until I test the device how does it actually perform, how much current can I get at different combinations of input and output voltage, and power dissipations before I cause a thermal shutdown and things like that. So I think this is going to need some characterization, but I didn't buy stuff like this to try putting it to its limits. It looks like here, let's say we go with half an amp. Looks like we can be pretty stable, so as long as it works, that's fine. And I believe I know what these are all about. These are dual ganged pots. Probably 10K. So we got dual ganged pots. You turn the knob and both variable resistors will change at the same time. These tabs may be a little bit too big to be breadboard friendly, but really it doesn't matter as long as I can make it work. This is the bridged T filter that I was working on, where it's got two 10K pots, and usually they are supposed to move at the same time, and I was trying to do it this way just to get something going, but I found it's probably best to have the correct part for the job. I wasn't getting the results I wanted. This was from one of the fail videos, so I'm hoping for success with this. 5 pieces 10K dual pots, 15mm split shaft 6-pin. Satisfy Electronics, $1.56 US. They are linear taper, carbon film. So if you need to figure out about making sure you get the right knob, you can use these specs on the shaft, and it's a split shaft, not one of those D shaft things. Good price to get 5 of these as long as they work relatively cleanly, for now at least. I think if I really wanted to, I could jam this into a breadboard, but it would probably ruin it. And the spacing may just work for going across the center, especially if I bend these out a little bit. But I think what I'm going to do is just get some smaller 0.1 inch headers like the kind on all of these modules and just attach them so I can put that into the breadboard and not ruin it. Expansion board module quantity 1. Well, can never have enough expansion board modules. It helps you expand things, and that's how you learn and grow. So this one, I don't know, I don't recognize it. So it's got a 3-pin header. This looks like an Electret microphone with adjustable gain. So you got power, ground, and out. Ooh, there's a very tiny chip 5-pin thing here and some sort of adjustable, I guess that's the adjustable gain, tiny trimmer pot. I can't really make out the part labeling on here. Maybe the listing describes the circuitry. And it can run 2.4 to 5.5 volts, so Arduino friendly. As usual, I think I just wanted this for general purpose things. I looked this up. I bought it last December. This is one of those stragglers that are sitting in the bottom of the bin. I just reached down today and I got some that were received this week, and this one was received probably in January. GY Max 4466 Electret microphone amplifier with adjustable gain for Arduino. $1.69 American from Alice 110 1983. Add an ear to your project with this well-designed Electret microphone amplifier. The microphone covers the entire audible frequency range, 20 Hz to 20 kHz. And one of the example projects here, projects that use FFT, which sounds to me like the spectrum analyzer display. But if you also have one of those audio recorders that can record onto an SD card or something, or a voice changer, you can use a module like this as a quick microphone. And it has a small trimmer pot for the gain on the back. And the amplifier is not really a power amplifier, so just tiny in-ear headphones at best. They use a Maxim Max 4466 op amp specifically designed for this task. Oh, this delicate task. So, why read the blurb? Let's just see what the datasheet says. Yes, Max 4466 is a microphone preamp. Looks like it's designed for low voltage, low current applications. It comes in a tiny package, so it looks like a good, easy way to just get a simple microphone integrated into a tiny project. Haven't had a plastic sheet in a few weeks. Let's see what this one's all about. Okay, a plastic sheet that looks like PTC resettable fuses. I'm pretty sure I ordered these a long time ago, but it doesn't mean they took forever. It took me forever to open them. So these, I'm not sure now which ones I got, and I'm not sure what the markings mean on the bag. Let's see if I can see anything more clear on the part itself. The larger one looks like it says JK60 and then 090. Is that 0.9 amps or something? I think the small one says 020. We'll have to look this up and track down what it is. But if these are PTC resettable fuses, what happens is if you exceed the trip point of the current rating, these will open up and act as a fuse, but when you take power away and they cool down, they reset. So all you basically have to do is a power cycle with enough time to let these reset, and your circuit won't be destroyed and you don't have to replace fuses. The first time I ever used something like this was in a high current DC motor, and it was there as a safety feature because the design requirement was if the motor driver gets short-circuited, it won't blow up, catch fire, stuff like that. And if there's a short circuit, you're going to want to power the machine down anyway. So when these trip, and these would be set well enough beyond the normal average and peak run, so they don't get nuisance tripping. But if you do get a short circuit, these will trip, the machine will have to be taken offline, and you can troubleshoot it. Then boot up, and it should be all safe. 20 pieces of PPTC, PTC DIP resettable fuse, JK60-090, which is a 60 volt, 900 milliamp. 20 of those for 99 cents US from Horizon Electronic. Haven't bought from them in a while. The brand is JinKe or JinKe or something. The way they've capitalized this, it's like it's two separate syllables, not jink. So it's a Polymer PTC resettable fuse. So you can get these with a hold current between 100 milliamps and 3.75 amps. And this JK series can handle 60 volts. So the 090 I got, which is 900 milliamps, can handle a maximum current of 40 amps and a maximum voltage of 60 volts. And I guess this spec here means the inline resistance added is only 0.2 to 0.33 ohms, so it's not really invasive. And I also got 10 pieces of the 250 volt 20 milliamp JK250-020. These, I guess, being higher voltage. Even though it's a lower current, it's higher voltage. You only get 10 and you pay more than double, $2.15 US from Horizon Electronic. So this is just a different link for the other family, the JK250-020. Now they give the specs I'm more used to when I used these before. There's a hold current and a trip current rating. So this 20 milliamp part, it has a hold current of 20 milliamps. I believe what that means is when you start exceeding 20 milliamps, I think if you're between 20 and 45, eventually, I guess, you'll actually warm up enough, or whatever the situation is, that you eventually trip. If you have 0.5 amps, it'll take you half a second to trip. Now these look like they have a higher resistance, 80 to 160 ohms. So depending on your application, if this is not a problem, then this might be a suitable device so you can have a resettable fuse. I believe this one is actually described accurately as foam pad. This could be almost anything, even if it looks like it's described properly. No, it's a foam pad wrapped in bubble wrap to protect it. Which might make sense. It helps keep it, you know, from getting ripped or something in transit. Who knows? Okay, this is one of those over-taped things. Try not to cut myself with this deadly package opener. And again, something to open. I'm just not having luck today. Careful. Just give it a vulnerable tear and we should be able to rip it open. So these are relatively thin. I'm not sure, but the listing will tell me. And put them on these 10mm grids. It looks like it's just over half a centimeter, so I'm going to go with 3mm thick. The length and width take up 20 squares, so 200mm by 200mm by 3mm, I'm going to guess. And these are supposed to be either conductive foam or at least non-static generating foam. So I was hoping I could maybe use it as a foam pad to store components like this one, even though it's not the same kind of density. So I don't know if it works for that. I guess it could. I can get, you know, 15 to 30 megs on the meter all around. And my old conductive foam that I've had for a long time, well, this gives me like 3.8 or so kilo ohms all around. So this is really conductive foam. 3mm ESD antistatic high density foam, 200 by 200mm. $1.45 per sheet from Honesty 2015. I wonder when they signed up. Ha! 2015. So this foam, they are showing some interesting things here. It's thin, high density, and maybe flame resistant. I did a little research on EVA. There are a lot of uses for this, including cushioning, insoles for shoes, things like that. But I wonder if you could actually use this, maybe this is a test I can do, to kind of use with a blowtorch when you're doing plumbing and you line the back end if you want to protect a wall stud or something else so you don't burn it when you're trying to do some plumbing. They are showing a measurement of 10 to the 5 ohms per square, which is 100K, but I was measuring between 10 and 20 or so megs at pretty much all distances along here. But yeah, that's the difference between conductive foam and static dissipative foam. I'm going to call this a static dissipative material because, well, my conductive foam was what, less than 4K? So the material is EVA. It's a closed cell foam, so it's got water resistance, anti-moisture, some degrees of corrosion resistance from acids and harsh chemicals. It's easy to cut and form into things. People, I think, make live-action role-playing weapons and armor out of stuff like this too. Flame retardant to V0 standards. I don't know what those standards are, but will it handle a blowtorch? So there's a lot of properties that this might be able to be used for, aside from anything electronic. EVA, ethylene-vinyl acetate. It is used in all kinds of things, including flip-flops. Hey, can I make a D flip-flop out of this? EVA polymer milk. Okay, this is getting a bit dystopian on me. I'm gonna just move on. So this whole document here kind of made me a little more confused than clarified, trying to figure out what is the difference between antistatic and conductive, dissipative, shielding against electrostatic. So surface and volume resistance in ohms, well, either way, greater than 10 to the 4 and less than a whole lot more resistance. Well, if they measured in that picture 10 to the 5, 100K, and I measured 10 or 20 megs, this on the surface, or in the volume, I guess this is dissipative foam. My other foam, where it was less than 4K, would be conductive foam. So I don't know exactly what I'm allowed to use this for with electronics in terms of, can I stick some static sensitive parts on this? Or do I need to actually ground it like a mat? Because this will help dissipate slowly any charge, but if I bring a charge to it and it's a floating surface, like if I throw it in a container and put parts on it, then it comes in contact with some electrostatic energy. Well, what happens? I'm not really clear. So either way, this has a million uses, so I'll figure it out as I go. So we've got some resettable fuses, some static dissipative, hopefully foam, dual gang 10K pots, Electret microphone with preamp, RGB gesture sensor, and some switching regulators.